In the following example, we've been asked to factor out the greatest common factor from the expression 39x squared y cubed z minus 42x y squared z squared plus 18x y squared z cubed. The first thing to note is that with the coefficients 39, 42, and 18, we need to find the greatest common factor of each one. And we'll note that 39 has a factor of 3 and 13. So either 13 is a factor of all three factors, all three coefficients, which it isn't, or 3 is. And we'll note that, yes, 39 is divisible by 3 as 13, so that will be our coefficient right here. 42 is divisible by 3 is 14, and 18 divisible by 3 as 6. Each term also contains a factor of x. The first term contains x squared, the second term contains x, the third term contains x, so 3x. X is part of our greatest common factor. Y cubed, y squared, and y squared share a common factor of y squared, so that's going to be part of our common factor. Z, z squared, and z to the third share a common factor of z, so that would be part of our greatest common factor. Now we have to think, what would we multiply 3xy squared z by to get 39x squared y cubed z? For the coefficient, we must multiply 3 times 13 to get 39. X is multiplied by x to give us x squared. Y squared is multiplied by y to give us y to the third. And z is all by itself in this one. 42, to get 42, 3 has to be multiplied by 14. X comes factored out completely. Y squared as well. And z squared is obtained by multiplying z times z. In the last term, 18 contains a factor of 6. X gets factored out, y squared gets factored out, leaving us with a factor of z squared. This is our factored form, and so we're done.